The silence of the intergalactic medium is not merely the absence of sound, it is a profound, heavy weight that has pressed against the fabric of the cosmos for eons. In the vast, stretching deserts between the Great Attractor and the lonely gossamer filaments of the cosmic web, time flows like a slow, dark river, undisturbed by the frantic pulse of planetary life. Here, the vacuum is almost absolute. A single atom of hydrogen might wander for 1,000 years through the abyssal cold before encountering another of its kind. It is a realm of the highest order of stillness, a place where the laws of thermodynamics seem to hold their breath in anticipation of a change that never comes. In this pristine emptiness, a solitary sun has stood its ground, far from the crowded, swirling arms of any host galaxy. It was an exile, a hermit of the deep, maintaining a lonely vigil that spanned more than 1 billion years. This star was a steady, unblinking eye in the dark, a point of light that served as a fixed reference for a universe that otherwise drifted in the relentless grip of chaotic expansion. Then, the stillness broke. The rupture did not begin with a whisper or a slow decay, but with a needle of pure ultraviolet fire that pierced the very heart of the vacuum. This was not the predictable bloated death of a red giant or the rhythmic pulsing of a white dwarf. This was a sudden, catastrophic failure of the local geometry of space. The star, having exhausted the delicate internal balance that held gravity at bay for an eternity, did not merely fade into the shadows. It chose to conclude its billion-year vigil by shredding the local fabric of space-time. The core, compressed beyond the physical limits of known matter, screamed as it collapsed inward, while the outer layers were flung outward at a significant fraction of the speed of light. The result was a fountain of radiation so intense that it redefined the boundaries of the visible spectrum. Ultraviolet light, invisible to the human eye but devastating to the structure of reality, tore through the dark like a blade. This event stands as the black swan of the heavens, a phenomenon that defies every chapter of the established scientific text. In the meticulous ledgers kept by those who study the heavens, there are rigid rules for how a sun must live and how it must die. There are blueprints for the life cycles of the stars, categorizing them by their mass, their temperature, and the heavy elements they forge in their nuclear bellies. But this burst, designated as AT2023FHN, represents a statistical impossibility made manifest. It is an outlier that exists far outside the bell curve of cosmic probability, a masterpiece of destruction that mocks the orderly models of the past. Where the universe usually demands millions of years for a massive star to transition from its prime to its violent end, this event compressed the agony of a solar system into a matter of days. The shattering of this isolated world became the brushstroke for a new cosmic era, a signal sent across the void to announce that our understanding of the heavens is still in its infancy. Light did not merely radiate from this point of collapse, it screamed into the void. The energy released in those first few hours eclipsed the total combined output of entire galaxies. If a standard supernova is a lantern flickering in a dark forest, this was a forest fire that consumed the very concept of the forest itself. The vacuum, once cold and indifferent, was suddenly flooded with a tide of high-energy photons that carried the signature of a newborn monster. This was a luminous, fast blue optical transient, a term that feels far too clinical for the raw, unbridled power it represents. The blue at the heart of this explosion is not the soft azure of a terrestrial sky, but the searing, terrifying heat of a plasma that has forgotten how to be matter. It is a heat that reaches 20,000 degrees, a temperature so high that it strips the electrons from every atom it touches, creating a roiling sea of ions that expands into the emptiness at millions of miles per hour. As the light travels across the vastness, crossing the gulfs between the stars and the empty spaces between the galaxies, it carries the story of a lonely fire in the deep. It is a fire that, by all the laws of stellar evolution, should not be there. It challenges the comforting notion that the universe is a predictable machine governed by easily understood cycles. Instead, It reveals a reality where the most profound and transformative events occur in the most isolated and unexpected places. The shattering of the star is not an end, but a transformation of the highest order. It is the moment where the potential energy of gravity, stored for 1 billion years, is converted into a spectacle that outshines the sun 10 times over. This is the opening act of a cosmic drama that forces a rethinking of the very nature of black holes, the lifespan of massive stars, and the hidden dangers that lurk in the dark. The void is no longer silent. It is vibrating with the echoes of a sun that refused to go quietly into the night, choosing instead to tear a hole in the universe and let the light of its own destruction illuminate the path for those who are watching from the far side of the dark. For the vast majority of our history, we looked upon the night sky and saw a monument to permanence. To the ancient observer, the heavens were a crystalline vault, an immutable museum where the stars were fixed like diamonds upon a velvet canopy. This celestial architecture was a source of profound comfort, a silent gallery that remained unchanged while the brief, frantic lives of men rose and fell in the dust below. We named the constellations as if they were eternal sentinels, believing that the order of the cosmos was a reflection of a divine and static perfection. The sky was not a place of action, but a place of record, a map of the gods that existed beyond the reach of time, decay, or violence. This was the era of the museum, where the light of the stars was perceived as a steady, frozen glow, a light that had always been and would always be. But the invention of the glass lens and the subsequent refinement of the silicon eye shattered this illusion of tranquility. As our instruments grew more sensitive, the museum was revealed to be a lie. The crystalline vault cracked, and through the fissures we glimpsed the true nature of the reality we inhabit. The universe is not a silent gallery. It is a living, breathing engine of creative carnage. It is a tempestuous furnace of unimaginable scale, where the birth of a galaxy is fueled by the collision of primordial gas, and the death of a sun is the prerequisite for the birth of a planet. We transitioned from being observers of a painting to being witnesses to a riot. Every point of light in the sky is now understood to be a site of frantic nuclear struggle, a sphere of plasma held in a delicate temporary truce between the crushing inward pull of gravity and the explosive outward pressure of fusion. This realization transformed the heavens into a landscape of constant, restless change. We began to see that the universe operates on a cycle of destruction that is as beautiful as it is terrifying. The heavy elements that comprise our bones, the iron in our blood, and the gold in our wedding bands were not present at the beginning of time. They were forged in the hearts of dying stars and scattered across the void by the very explosions we once feared. This is the central paradox of our existence. We are the children of catastrophe. The creative carnage of the cosmos is the only reason we are here to observe it. Without the shattering of suns, there would be no complexity, no chemistry, and no consciousness to wonder at the dark. The universe must break itself apart to build something new, consuming its own substance in a relentless pursuit of higher forms of matter. Yet, even within this modern understanding of a dynamic universe, we still harbour expectations of order. We expect stars to die in predictable ways, following the well-trodden paths of the stellar life cycle. We expect the massive ones to collapse into black holes and the smaller ones to fade into white dwarfs. We expect the explosions to happen where the fuel is, in the crowded, bustling neighbourhoods of galaxies where gas and dust are plentiful. We have drawn blueprints for the heavens, mapping out where the fires should burn and how long they should last. We have grown comfortable with the violence, categorising it and filing it away into neat scientific boxes. We convinced ourselves that we finally understood the rhythm of the cosmic engine. Then the silence of a supposedly empty room was pierced by a sudden blinding scream. This was the arrival of a T2023 FHN, an event that acted as a violent reminder of how little we truly know. It was as if a light had been switched on in a dark basement we believed to be vacant, revealing a monster that shouldn't exist. In the deep, intergalactic void, a place where the density of matter is so low that it shouldn't be able to support the birth of a massive star, a flare erupted with a ferocity that defied every model in our possession. It was not a slow, expected brightening, but a sharp, jagged spike of energy that reached its zenith in a matter of days. This burst, nicknamed the Finch by those who tracked its ghost, represents the ultimate subversion of our cosmic maps. It is a reminder that the universe still possesses the power to shock us, to present a black swan that invalidates our most cherished theories. AT 2023 FHN is the embodiment of the beautiful chaos, a singular event that stands alone in the dark, far from the safety of the galactic shores. It tells us that the most profound beauty is often born from the most absolute annihilation, and that this annihilation can occur anywhere, at any time, without warning. The scream in the empty room was not just a signal of a dying star, it was a challenge to our understanding of the engine itself. It forced us to look away from the crowded centres of the universe and toward the lonely, forgotten spaces, where the rules of the museum no longer apply and the carnage of creation continues in its most raw and mysterious form. We are now forced to reckon with a reality where the void is not empty, and where the most spectacular fires are those that burn when no one expected to find a spark. The vigil began not with a human eye pressed to a glass lens, but with the cold, mechanical precision of a global network of sentinels. Across the volcanic peaks of Hawaii, the high, arid plateaus of Chile, and the desolate reaches of South Africa, a series of robotic eyes remained fixed upon the rotating vault of the night. This is the Asteroid Terrestrial Impact Last Alert System, a name that suggests a defensive shield against the rocky debris of our own solar system. Its primary purpose is to scan the darkness for the faint moving shadows of near-Earth objects, hunting for the stones that might one day threaten our world. But in the early months of the year 2023, these sentinels caught a glimmer of something far more distant and far more disturbing than a stray asteroid. They captured the birth of a ghost. The detection occurred during a routine sweep of the sky, a process where the telescopes compare new images against a library of the old. In a patch of the void that had been unremarkable for as long as human records existed, a pixel of light suddenly saturated the silicon sensors. It was flagged by the automated software as an anomaly, a transient event that demanded further scrutiny. At first, the researchers expected the familiar signature of a standard supernova, the long, slow climb to brilliance that usually defines the death of a massive star. In a typical stellar explosion, the brightness builds over the course of several weeks as the shockwave tears through the outer layers of the star and the radioactive decay of nickel-56 fuels a lingering glow. This is the predictable rhythm of the heavens, a cadence that astronomers have studied for over a century. But as the data from the telescopes in Hawaii and South Africa began to synchronize, the technical shock among the observers became palpable. This new source, designated AT 2023 FHN, was not following the rules. It did not climb the mountain of its own luminosity with the measured pace of its peers. Instead, it erupted. Within a mere 3 days, it had reached a peak brightness that rivaled the output of billions of suns. It was a vertical spike on the light curve, a sudden and violent injection of energy into the vacuum that defied the standard models of stellar collapse. By the time the fourth day had dawned on the observatories of the southern hemisphere, the source had already begun to flicker, its brilliance as fleeting as it was intense. The urgency of the discovery rippled through the global astronomical community like a shockwave. This was not a mere variation of a known phenomenon. It was a signal of something fundamentally different. The rapid rise in luminosity suggested a central engine of terrifying efficiency, a heart of darkness that was converting mass into pure light at a rate that challenged the known limits of nuclear physics. The observers realized they were not looking at a standard death, but at a rare and exotic species of explosion. The Finch, as it would come to be known, was a scream in the dark that demanded the attention of every major instrument on and off the planet. Within hours of the initial alert, the hierarchy of celestial observation was upended. Time on the world's most powerful telescopes, usually booked months in advance, was diverted. The digital commands were sent to the Hubble Space Telescope, orbiting high above the interference of the atmosphere, and to the Gemini South Observatory in the Chilean Andes. The goal was to capture the fading embers of the burst before they vanished back into the shadows. There was a sense of frantic desperation in the control rooms, a realization that they were witnessing a black swan event, a phenomenon so rare that many astronomers spend their entire careers without seeing a single one. As the first high-resolution images returned from Hubble, the shock deepened into a profound mystery. The light of T2023 FHN was not just bright, it was extraordinarily blue. This colour served as a thermal fingerprint, indicating a surface temperature that exceeded 20,000 degrees. It was a heat so fierce that it pushed the boundaries of the ultraviolet, a searing radiation that spoke of a core that had been stripped bare and exposed to the cold of the void. But even more unsettling than the heat was the location. As the researchers overlaid the new images with deep-field maps of the cosmos, they found that the burst was happening in a place where no such event should be possible. The telescopes revealed that the Finch was not nestled within the protective, gas-rich arms of a galaxy. It was drifting in the intergalactic wilderness, roughly 50,000 light-years away from the nearest shore of organized matter. This revelation sent a tremor through the foundations of the core collapse theory. Massive stars, the only known progenitors of such violent transients, are born in the dense clouds of galactic nurseries and die long before they can wander so far into the empty dark. The discovery of AT2023 FHN was no longer just a technical curiosity. It was a direct challenge to the blueprints of the heavens. The silent network of sentinels had not just found an explosion, they had found a paradox that threatened to rewrite the story of how the stars themselves are allowed to end. Every eye on the planet was now fixed on that lonely point of ultraviolet fire, waiting to see what other secrets the beautiful chaos would reveal before the light finally failed. To understand the nature of the Finch is to confront the classification of the luminous fast blue optical transient, a name that serves as a clinical shroud for a phenomenon of staggering violence. Each word in this scientific designation is a pillar of a new and terrifying astrophysics, marking a departure from everything we once believed about the death of suns. Luminous denotes a power that dwarfs the collective output of billions of stars, a radiance so absolute that it can be seen across the vast, light-year spanning gulfs of the cosmic ocean. Fast signifies a temporal distortion, where the agonizing death throes of a celestial body are compressed into a mere flicker, a sharp and jagged peak on a graph that usually describes the slow, rhythmic breathing of the heavens. But it is the word blue that carries the most profound physical weight, for in the language of the cosmos, colour is the ultimate arbiter of temperature and energy. In the familiar world of the terrestrial, we associate blue with the calm of a clear sky, or the cool depths of a mountain lake. In the furnace of the stars, however, blue is the colour of a nightmare. It is the herald of extreme energy, the signature of a photon that vibrates with a ferocity that pushes toward the invisible destruction of the ultraviolet. While the surface of a sun like our own glows with a modest yellow warmth of 5,500 degrees, the surface of a luminous fast blue optical transient burns with a temperature that exceeds 20,000 degrees Kelvin. This is not merely a measurement of heat, it is an indicator of a state of matter that has transitioned beyond the familiar. At such intensities, the very structure of the atom begins to fail. The electrons are stripped from their nuclei with a ferocity that turns the surrounding gas into a roiling incandescent plasma, a sea of ionized particles that glows with a light so pure and so energetic that it defies the traditional limits of thermal radiation. This blue heat represents an extreme state of matter that glows with a ferocity beyond the reach of ordinary suns. It is the visible manifestation of a central engine that is pumping energy into the surrounding wreckage at a rate that traditional nuclear fusion cannot explain. If a standard supernova is a slow-burning bonfire fueled by the radioactive decay of heavy elements like nickel and iron, then this blue transient is a blowtorch, a concentrated jet of energy that vaporizes everything in its path. The heat is so intense that it creates its own pressure, driving the expansion of the stellar debris at speeds that approach a significant fraction of the light speed limit. It is a masterpiece of thermodynamic efficiency, converting the gravitational collapse of a world into a blinding, short-lived scream of ultraviolet fire. These events are the ultimate outliers of astrophysics, the black swans that haunt the data of our modern surveys. They are far brighter and hotter than any standard stellar explosion known to science, appearing as ghosts in the deep intergalactic void. In the hierarchy of celestial catastrophes, they exist in a category of their own, mocking the orderly classifications of the past. A standard supernova might linger in the sky for months, a fading ember that provides astronomers with ample time to dissect its light and understand its origin. But these blue transients are ephemeral. They arrive without warning and vanish with an unsettling speed, leaving behind only a trail of questions and a sense of profound mystery. They are the phantoms of the vacuum, appearing in the most unexpected places and disappearing before the mechanisms of our understanding can fully grasp their form. The physical significance of this phenomenon lies in its defiance of the established blueprints for the life cycles of the stars. In a universe governed by the slow, predictable laws of entropy, the luminous, fast blue optical transient is a sudden, violent rebellion. It is a reminder that there are processes in the dark that we have yet to name, engines of destruction that operate on scales and temperatures that push our mathematical models to the breaking point. The blue light of the finch is not just a colour, it is a signal of a higher order of physics, a glimpse into a realm where gravity and electromagnetism collide with such force that they create a new kind of fire. This is the fire that burned 50,000 light-years from the nearest galaxy, a lonely, brilliant ghost that forced us to acknowledge that the deep is far more active and far more dangerous than we ever dared to imagine. As we study these outliers, we are forced to move beyond the comfort of the known, following the trail of this blue heat into the heart of the beautiful chaos, where the rules of the old museum are burned away by the light of 1,000 suns, concentrated into a single fleeting moment of absolute annihilation. The temporal rhythm of the cosmos is usually measured in the slow, agonizing crawl of geological epochs. Stars are born in the quiet collapse of gas clouds over millions of years, and they burn with a steady stoic resolve for billions more. Even their deaths, the supernovae that have long served as the benchmarks of celestial violence, are characterized by a certain predictable leisure. A standard supernova is a mountain of light that takes weeks to climb. It begins with a sudden brightening, followed by a steady ascent as the shockwave hammers through the stellar envelope, eventually reaching a plateau where it lingers, fueled by the radioactive decay of nickel-56. This glow can persist for months, a fading ember that provides a long, illuminated trail for astronomers to follow. There is a protocol to these deaths, a recognized curve of luminosity that allows the scientific community to track the pulse of a dying sun with the precision of a metronome. But the event designated AT2023FHN shattered this metronome. It presented a temporal paradox that defied the very notion of how a star is permitted to die. Where a traditional supernova is a slow-burning fire, this transient was a lightning strike in the dark. It did not climb the mountain of its own brilliance, it materialized at the summit. Within a mere 3 days, it had surged from invisibility to a peak of such terrifying intensity that it threatened to overwhelm the sensors of the telescopes watching it. This erratic, lightning-fast rise was followed by an equally abrupt collapse. Before the global community of researchers could even finish calibrating their instruments to capture its spectrum, the light began to fail. It vanished into the dark with an unsettling speed, leaving the world's most powerful observatories to hunt for a phantom. The scale of this energy release is difficult to reconcile with the brevity of its duration. At its zenith, the finch burned 10 times brighter than the power of 5 billion suns. This is a quantity of light that staggers the mathematical imagination, 50 billion suns worth of radiance concentrated into a single, localized point in the intergalactic void. To produce such a staggering output, the central engine of the explosion must have been operating at an efficiency that pushes the boundaries of known physics. In a standard supernova, the energy is diffused through a massive shell of expanding gas, creating a lingering glow. In the case of the Finch, the energy was a concentrated scream, a pulse of pure power that was snuffed out before the echoes of its birth could even settle in the surrounding space. This rapid decay suggests a lack of the radioactive elements that typically sustain the light of a stellar explosion. If there were no massive quantities of nickel-56 to fuel the afterglow, then the source of the light must have been something far more exotic and far more fleeting. Researchers are left to grapple with the possibility of a newborn magnetar, a neutron star with a magnetic field a quadrillion times stronger than the Earth's, spinning at hundreds of revolutions per second and dumping its rotational energy into the void in a single frantic burst. Alternatively, they must consider the voracious appetite of a black hole, suddenly finding a meal in the middle of nowhere and radiating the heat of its final moments before falling back into silence. The frustration of the scientific hunt cannot be overstated. By the time the call went out to the great terrestrial and orbital eyes, the object was already a ghost. It was a race against a clock that was ticking at a rate the universe rarely demands. Astronomers were forced to work with empty plates, analysing the data from the few days of peak brilliance and trying to reconstruct the anatomy of a monster that had already retreated into the shadows. The transient left behind no long-term remnant that could be easily studied, no expanding nebula that would glow for centuries. It was a clean, sharp rupture in the timeline of the void, a fire that consumed itself with such ferocity that it left nothing but a question mark in its wake. This temporal paradox challenges the fundamental blueprints we have drawn for the life cycles of the suns. We have long believed that the more massive and energetic the event, the longer its signature should linger in the sky. But a T2023 FHN proved that the most absolute annihilation can also be the most ephemeral. It suggests that there are pathways to destruction that bypass the slow, radioactive decay of the elements, opting instead for a direct, violent conversion of mass into light. This event was a flame that burned with the intensity of 50 billion suns, only to be extinguished in a heartbeat, a phenomenon that forces us to reconsider the limits of stellar mortality. It reminds us that the universe is not just a place of slow, predictable change, but a realm where the most catastrophic events can occur with a speed that leaves our understanding gasping to catch up. The Finch was not just a burst of light. It was a temporal anomaly that proved the dark is capable of swallowing even the most brilliant fires before we have the chance to truly see them. The precision of the Hubble Space Telescope and the sharp terrestrial gaze of the Gemini South Observatory combined to reveal a geographical truth that was perhaps more unsettling than the explosion itself. In the standard cartography of the cosmos, the most violent events are expected to occur within the most crowded neighbourhoods. Galaxies are the great metropolises of the universe, swirling islands of gas, dust, and billions of suns where the cycle of stellar birth and death is a constant, frantic industry. It is within these glowing spiral arms that massive stars are forged in dense nurseries of molecular hydrogen, and it is there, near their birthplaces, that they inevitably meet their spectacular ends. Every previous observation of a luminous, fast blue optical transient had followed this rule, appearing deep within the star-forming regions of vibrant active galaxies. But the event designated AT2023 FHN was found drifting in the utter isolation of the intergalactic desert. As the researchers overlaid the pinpoint of ultraviolet fire onto the deep field images of the surrounding sky, they found no host galaxy beneath it. Instead, they discovered that the burst had occurred roughly 50,000 light-years away from the nearest shore of organised matter. This distance is staggering. It is a gulf equivalent to half the diameter of the Milky Way, a vast and empty reach of space where the density of matter drops to almost nothing. The Finch was not a resident of a galactic city. It was an exile in the abyssal silence of the deep. This location creates a mystery that defies the geographical laws of the heavens. To find such a massive release of energy in the void is akin to finding a volcanic eruption in the middle of a calm, frozen ocean. The intergalactic medium is a realm of gossamer filaments and cold vacuum, a place where there is simply not enough raw material to build the kind of massive star typically required to fuel such an explosion. Massive stars are the giants of the stellar world, often possessing 20 or 30 times the mass of our own Sun, but their lives are as brief as they are brilliant. They burn through their nuclear fuel with such profligacy that they die within a few million years of their birth. The paradox of the finch lies in the mathematics of travel. Even if such a star had been born within the distant galaxy and somehow been ejected into the void by a gravitational encounter with a black hole, it would have to travel at impossible speeds to reach a point 50,000 light-years away before its time ran out. The laws of physics suggest that a star of that magnitude would have collapsed into a supernova long before it ever reached the halfway point of its journey into the dark. Therefore, the presence of this explosion in the middle of nowhere suggests one of two disturbing possibilities. Either massive stars can somehow form in the near vacuum of intergalactic space, or the finch was not a star at all. The void is a place where we expect to find nothing but the faint ancient glow of the cosmic microwave background and the lonely transit of rogue planets. It is a desert where the light of distant galaxies is the only landmark. By erupting in this isolated theatre, AT 2023 FHN forced astronomers to look at the empty spaces between the stars with a new sense of trepidation. It revealed that the nothingness we have mapped for centuries is capable of producing events that outshine the somethingness of the galaxies themselves. The isolation of the burst serves as a stark contrast to the crowded, gas-rich environments we are used to studying, highlighting our profound ignorance of the processes that govern the fringes of the cosmic web. This location paradox transforms the event from a mere astronomical curiosity into a fundamental challenge to our understanding of stellar evolution. We are forced to ask what kind of object can survive the journey into the deep, or what kind of invisible process can gather enough matter in the void to trigger a 50 billion sun explosion. The Gemini South Observatory, perched on its mountain in Chile, captured the fading light of this lonely fire, providing the evidence that the finch was a true orphan of the cosmos. It was a sun that died in a place where no sun should have been, a ghost that appeared in a room we were certain was empty, and in doing so, it rewrote the map of the violent universe. The beautiful chaos does not limit itself to the centres of power. It reaches out into the farthest, darkest corners of the vacuum, proving that even in the most desolate intergalactic desert, the engine of destruction is never truly silent. The established doctrine of stellar death rests upon a singular, elegant mechanism known as the core collapse model. For decades, this has been the cornerstone of our understanding, a physical law that dictates how the most massive suns in the cosmos must meet their end. These stars are the titans of the universe, celestial giants that possess 10, 20, or even 50 times the mass of our own sun. Their lives are defined by a frantic, high-stakes struggle against the relentless, crushing force of their own gravity. To prevent themselves from collapsing into a singularity, they burn through their internal reservoirs of hydrogen and helium with a profligate intensity, creating an outward pressure that maintains a delicate temporary equilibrium. They are the rock stars of the heavens. They burn with a brilliant blue-white ferocity, but their lives are fleeting. Where a smaller star like our Sun might endure for 10 billion years, these massive titans exhaust themselves in a mere few million. This brief lifespan creates a fundamental constraint on where these stars can be found. Because they die so young, they do not have the time to wander far from the galactic nurseries where they were born. They are tethered to the dense clouds of gas and dust within galactic arms, the only places with enough raw material to forge such massive bodies. If a massive star were to be ejected from its home galaxy, perhaps by the gravitational slingshot of a binary partner or the influence of a supermassive black hole, it would become a runaway star, hurtling through the void at hundreds of kilometers per second. Yet, even at these extreme velocities, the clock of its own nuclear decay is ticking. To reach a point 50,000 light-years away from the nearest galactic shore, a star would need to survive for tens of millions of years. For the massive progenitors of luminous transients, this is a biological impossibility. They would turn into a supernova and scatter their remains across the vacuum long before they reach the halfway mark of such a lonely journey. The discovery of AT 2023 FHN thus creates a profound tension between established physics and the reality of this distant, impossible fire. The light captured by our sensors tells the story of a massive explosion, yet the location tells the story of a place where no such star should reasonably exist. This paradox suggests that our maps of the life cycles of the suns are fundamentally incomplete, missing chapters that describe either a new way for stars to be born or a new way for them to die. If the core collapse model cannot account for the Finch, then we are forced to look beyond the standard blueprints of stellar evolution. We must consider the possibility that the intergalactic medium, once thought to be a barren wasteland, contains hidden pockets of density or forgotten mechanisms of creation that can spark a 50 billion sun explosion in the heart of the nothingness. The failure of the core collapse model to explain this event ripples through the entire field of astrophysics. It suggests that the black swans we are now detecting are not just rare versions of familiar events, but entirely different beasts altogether. Perhaps the universe has more than one way to produce a blinding blue flash. If it is not the collapse of a massive star, then the energy must come from an external source. A collision, a shredding, or a sudden, catastrophic accretion of matter onto a hidden object. The reality of the Finch implies that there are dark actors on the cosmic stage that do not rely on the traditional fuel of galactic nurseries. It hints at a population of objects lurking in the intergalactic void, silent and invisible until the moment they decide to tear the vacuum asunder with a scream of ultraviolet light. This discrepancy forces a reckoning with our own hubris. We have spent centuries observing the bright, busy centres of galaxies, assuming that the rules we learned there applied to the entire tapestry of the cosmos. We drew our diagrams of stellar life based on the crowded neighbourhoods we could easily see. But the Finch erupted in the outskirts, in the lonely desert where we assumed the laws of physics were dormant. By doing so, it revealed that the universe is not a monolithic machine with a single set of instructions. It is a complex, multi-layered reality where the most spectacular events can bypass the traditional pathways of birth and death. The tension between the short, frantic lives of massive stars and the vast, empty distance of the Finch's location is a crack in the foundation of our knowledge. Through that crack, we glimpse a universe that is far more mysterious and far less predictable than our models ever dared to suggest. The maps are being redrawn, and the new legends must account for the fact that in the deep, the rules of the museum are often ignored in favour of a more primal, beautiful chaos. The failure of the traditional stellar models forces the gaze of the observer toward a more sinister possibility lurking in the intergalactic wasteland. If the light did not come from a star reaching the end of its natural life, it may have come from a star that was murdered. In the vast, dark stretches between the galaxies, there exists a population of invisible ghosts known as medium-mass black holes. These are the middle children of the gravitational family, possessing a mass that ranges from a few hundred to several 100,000 times that of our Sun. Unlike the supermassive monsters that anchor the centres of galaxies, these intermediate predators are nomadic and silent, wandering the void without the brilliant accretion disks that usually betray their presence. They are the ultimate traps, sinkholes in the geometry of space that wait for the rare passage of a stray celestial body to reveal their location. A lone star, perhaps a long-lived sun that had drifted for billions of years since being ejected from its parent cluster, unknowingly crosses the invisible threshold of such a predator. There is no collision in the traditional sense, no impact of solid surfaces. Instead, there is a subtle, relentless stretching. As the star approaches the black hole, the gravitational pull on its near side becomes significantly stronger than the pull on its far side. This differential force, known as the tidal effect, begins to overcome the internal gravity that holds the star together. The star is no longer a sphere. It is pulled into an ellipsoid, then a needle, and finally it is unzipped. This is the process of tidal disruption, a mechanical dismantling of a world that occurs before the star even touches the event horizon. The fabric of the star is shredded into a long, glowing stream of gas that begins to wrap itself around the black hole like a ribbon of fire. This is not a quiet consumption. As the stellar debris is pulled into a tight, screaming orbit, the atoms are accelerated to a significant fraction of the speed of light. They collide with one another at extreme velocities, and the resulting friction and compression turn the kinetic energy of the star's motion into a blinding release of radiation. This is the source of the 5 billion sun luminosity, a flash that rivals the most powerful supernovae ever recorded. The gas is heated to tens of thousands of degrees, creating the searing blue-white glare that the telescopes in Hawaii and Chile captured across the gulf of 50,000 light-years. This scenario perfectly accounts for the fast nature of the transient. A supernova depends on the slow radioactive decay of forged elements to maintain its glow, but a tidal disruption event is powered by the immediate violent conversion of gravitational potential into heat. Once the bulk of the star is shredded and the initial feast is over, the light fades with unsettling speed. The finch was not the slow death of a titan, but the quick, messy feeding of a medium-mass black hole. The physics of the shredding create a furnace of kinetic destruction, where the mass of an entire sun is processed through the gravitational mill of the black hole in a matter of days. This explains why the event could occur in the middle of nowhere. While a massive star cannot travel 50,000 light-years before dying, a smaller, more stable star can wander the void for eons until it has the misfortune of stumbling into a gravitational trap. The medium-mass black hole itself remains a mystery of the deep. Astronomers suspect these objects are the stripped cores of ancient dwarf galaxies, the remnants of small stellar cities that were torn apart by the larger Milky Way billions of years ago. What remains is a lonely, dark heart, drifting through the intergalactic medium like a landmine from a forgotten war. When a stray star enters its domain, the resulting explosion is a masterpiece of destructive efficiency. The blue light of the transient is the signature of this extreme state of matter, a plasma so hot and so energetic that it pushes the limits of what a single point in space can radiate. In this quiet corner of the void, the shredding of the star becomes a beacon. For a brief moment, the invisible predator is unmasked by the very act of its consumption. The energy released in this encounter is so vast that it creates its own temporary environment, a bubble of light and heat in a place where the temperature is usually only a few degrees above absolute zero. This is the ultimate subversion of the cosmic order, a silent, dead object using the lifeblood of a star to create a spectacle that outshines 1,000 galaxies. The physics of tidal disruption provide a bridge between the impossible location and the terrifying power of the burst. It suggests that the intergalactic desert is not just a place of transit, but a hunting ground where the ghosts of ancient galaxies still exercise their lethal power. The beautiful chaos of the finch is thus revealed to be the final scream of a star caught in the grip of a predator that has waited since the beginning of time for its single, brilliant moment of revelation. At the core of this celestial violence, shielded by the expanding shroud of vaporized matter, lies a hidden power source of terrifying efficiency. This is the central engine, a term used by those who study the high-energy heavens to describe a heart of darkness that converts raw mass into pure, unadulterated radiation. In the case of the finch, the standard fuel of nuclear fusion, the slow, steady cooking of hydrogen into helium, is insufficient to explain the sheer scale of the output. To produce a flare that reaches its zenith in mere days and burns with the intensity of 50 billion suns, the universe must bypass the traditional pathways of stellar metabolism. It requires a mechanism that can pump energy into the surrounding environment at a rate that pushes the very limits of causality. One leading possibility for this engine is the birth of a magnetar, a neutron star of such extreme density and magnetic power that it defies the familiar laws of material science. When the core of a massive star collapses, it can sometimes leave behind a remnant the size of a city, but with a mass greater than that of the Sun. If this remnant is born spinning hundreds of times per second, it becomes a dynamo of unparalleled strength. Its magnetic field lines, trillions of times stronger than those of the Earth, are not merely invisible forces. They become physical structures that warp the vacuum itself. As the magnetar spins, it acts as a cosmic lighthouse, its magnetic fields dragging through the surrounding wreckage of the explosion. This process, known as magnetic braking, transfers the incredible rotational energy of the star directly into the expanding shell of debris. It is a direct injection of power, a mechanical shove that heats the gas to 20,000 degrees and drives it outward at a significant fraction of the speed of light. Alternatively, the engine may be an accreted black hole, a singularity that has found a sudden and overwhelming feast. In this scenario, the remains of the shattered star do not simply drift away. They are pulled into a tight, screaming disk around the event horizon. This accretion disk is a site of absolute friction, where the gravitational potential energy of the falling matter is converted into heat and light with an efficiency that dwarfs any nuclear reaction. The black hole does not just consume matter, it processes it, stripping the atoms of their identity and radiating their mass away as high-energy photons. Magnetic fields within the disk can also funnel this energy into twin jets of plasma that pierce through the stellar ejector, acting like thermal lances that keep the dark at bay. Whether a magnetar or a black hole, this central engine acts as a heart of pure energy, beating within the wreckage of a shattered world. It is a self-consuming mechanism that uses its own environment as fuel to maintain its brilliance. The blue heat that defines the luminous fast blue optical transient is the thermal signature of this relentless pumping. While a standard supernova relies on the radioactive decay of nickel to stay bright, a process that is slow and limited by the amount of material forged in the initial blast, the central engine is limited only by its own spin or the amount of matter it can pull into its maw. This explains the fast nature of the event. Once the engine exhausts its immediate fuel or its rotational energy, the light is snuffed out as quickly as it was ignited. The physics of this engine provide a glimpse into a realm where the fundamental forces of nature are concentrated into their most extreme forms. The magnetic fields are so intense they can distort the shape of atoms, turning them into elongated cylinders. The gravity is so powerful it can bend light into closed loops. Within this environment, the distinction between matter and energy begins to blur. The central engine is a furnace that operates at the threshold of the known, a place where the beautiful chaos of the explosion is organised and directed by the cold, mathematical laws of general relativity and electromagnetism. It is the reason the Finch could be seen across 50 million light-years of empty space. Without this heart of energy, the explosion would have been a mere flicker in the dark, a quiet death unnoticed by the sentinels of Earth. This engine is also a source of creative carnage. The energy it pumps into the ejector does more than just create light. It drives the synthesis of heavy elements, forging the building blocks of future worlds in a crucible of ultraviolet fire. The blue heat is the light of creation happening at an accelerated pace, a signal that the universe is still capable of generating new forms of matter through the most violent means possible. As the engine beats within the wreckage, it ensures that the death of the star is not a total loss, but a transformation. The energy that once held a sun together is released into the void, carrying with it the potential for new complexity. The central engine is the bridge between the absolute annihilation of the past and the infinite possibilities of the cosmic future, a lonely, brilliant heart that refuses to let the light fade until it has left an indelible mark upon the fabric of the vacuum. The standard by which all cosmic catastrophes are measured is the Type 1A supernova, a phenomenon so consistent and so powerful that it serves as the yardstick for the very expansion of the universe. When a white dwarf star reaches its breaking point and detonates, it releases a torrent of energy that radiates with the combined power of 5 billion suns. This is a number that already strains the limits of human comprehension, a single point in space outshining the collective light of an entire galaxy for weeks on end. It is a benchmark of absolute power, a standard candle burning in the dark. Yet, when placed alongside the event designated AT 2023 FHN, this benchmark begins to look like a mere flicker. The Finch did not just meet the energy output of a standard supernova, it eclipsed it by a factor of 10. At its peak, this transient erupted with the sheer magnitude of 50 billion suns. This is not merely a larger explosion, it is a different order of reality. If the energy of 5 billion suns is enough to illuminate the cosmic dawn, then 50 billion suns is a localized rupture in the energy density of the vacuum. This staggering radiance was not spread out over months of slow decay, but was concentrated into a brief, violent window of time spanning only a few days. The intensity of this light is so extreme that if such an event were to occur within our own galactic neighbourhood, it would strip the atmospheres from planets across thousands of light years, sterilizing entire sectors of space with a single pulse of ultraviolet fire. It is a concentration of power that represents the ultimate triumph of kinetic and gravitational energy over the stability of matter. The mathematical indifference of such an event is perhaps its most haunting quality. This explosion, capable of powering 1,000 advanced civilizations for billions of years, occurred in the absolute desolation of the intergalactic void. The energy released is equivalent to the total mass energy conversion of an entire solar system, yet it fell upon a vacuum so perfect that there was almost nothing to receive its warmth. In the crowded centers of galaxies, light is absorbed by dust, reflected by nebulae, and caught by the eyes of potential observers. But 50,000 light-years from the nearest galactic shore, this 50 billion sun flare was a scream in a padded cell. The photons travelled for millions of years across the emptiness, never touching a single atom until they finally reached the silicon sensors of our telescopes on Earth. There is a cold, calculated waste to this process that challenges our desire for cosmic purpose. We tend to view energy as a resource, something to be harnessed, conserved, and utilised for the advancement of complexity. Yet the universe treats this staggering output as a rounding error in a larger equation of entropy. To the machine of the cosmos, it does not matter if 50 billion suns worth of light illuminate a thriving biosphere or the frozen nothingness of the deep. The laws of physics are blind to utility. They demand only that the energy be released, that the gravity be satisfied, and that the equilibrium be restored. The Finch is a testament to this indifference, a furnace that consumed the substance of a world only to cast its light into a part of the universe where there was no one to see it and nothing to be changed by it. This scale of energy, when viewed through the lens of our own fragility, is a reminder of the true nature of the environment we inhabit. We live on a planet warmed by a single modest star, a sun that provides just enough energy to sustain the delicate chemistry of life. The Finch represents the output of 50 billion such stars, all firing at once in a single localized point of space. It is a reminder that the universe is not a garden designed for our comfort, but a high-energy laboratory, where the most extreme conditions are common and the most violent events are inevitable. The energy that could have fueled the evolution of a million species for eons was instead spent in a few days of blinding blue-white glory, leaving behind a cold, silent remnant and a trail of photons that tell a story of absolute, unmitigated waste. The sheer magnitude of the light concentrated into that brief window of time serves as a marker of the beautiful chaos. It is beautiful because of its purity and its defiance of the dark, but it is chaotic because it serves no end other than its own existence. It is a masterpiece of destruction that occurred in a place where there were no critics to witness it. As we measure the curve of its fading light, we are forced to reckon with the fact that the most powerful events in the universe are often those that happen in total isolation. The Finch was a 50 billion sun beacon in a desert of non-existence, a reminder that the cosmic engine is capable of producing spectacles of such scale that they render our concepts of value and purpose entirely obsolete. The light has now travelled past us, continuing its journey into the infinite dark, a ghost of an energy that was once great enough to challenge the very night itself, yet was ultimately destined to fade into the mathematical silence of the void. The intergalactic void does not mourn the passing of its stars. There is a terrifying purity in a cataclysm that occurs in the absolute isolation of the deep, where no planets are scorched by the ultraviolet fire and no eyes are present to marvel at the sudden rupture of the night. This is the ultimate expression of the mathematical indifference of the cosmos. To the fundamental forces that govern the movement of matter and the flow of time, the event designated AT 2023 FHN is not a tragedy, nor is it a miracle. It is merely a solution to a complex equation of gravity and thermodynamics, a necessary release of tension in the fabric of space-time. The universe operates on a scale where the total extinction of a solar system, the vaporization of its planets, the shredding of its sun, and the erasure of its entire history is treated as a mere rounding error in the vast, cold ledger of entropy. We are accustomed to searching for meaning in the light, yet the Finch reveals a reality that is fundamentally hostile to our concepts of purpose. The universe is a machine that builds only to break. It is a system designed to consume itself, a relentless engine that gathers primordial gas into the ordered structures of stars only to eventually tear them asunder in a display of creative carnage. Every sun is a temporary reprieve from the dark, a brief pocket of low entropy that exists only because it is destined to fail. The cosmos is a furnace that consumes its own children to keep the absolute zero of the void at bay for one more fleeting second. In this light, the star that fueled the Finch was not a sentinel or a guardian, but a fuel source that had reached its expiration, a bundle of energy that the machine finally decided to process. This perspective strips away the comfort of the celestial museum. If the heavens are a gallery, they are one where the paintings are constantly being slashed and the statues ground into dust to make room for new, equally temporary works. The sheer scale of the waste is what haunts the human observer. 50 billion suns worth of light were cast into a part of the universe where there was nothing to catch them, no world to warm, and no life to sustain. It was a masterpiece of destruction performed for an empty theatre. This indifference is the core of the cosmic experience. The universe does not care if its most spectacular events are witnessed, or if they occur in the most profound loneliness. It continues its work of breaking and building with a mechanical precision that renders our definitions of beauty and horror entirely irrelevant. Entropy is the only true master of this realm. It is the silent, invisible tide that pulls at every atom, demanding that order be returned to chaos and that energy be spread thin across the infinite reaches of the vacuum. The Finch was a brief, violent rebellion against this tide, a moment where energy was concentrated into a single, blinding point of order before being scattered into the dark. But even this rebellion serves the master. By exploding with such ferocity, the star accelerated its own journey toward equilibrium, turning its solid mass into a thin, cooling gas that will eventually become indistinguishable from the void itself. The furnace burns bright not to celebrate life, but to hasten the arrival of the end. It is a cannibalistic process where the past is ground up to provide the raw materials for a future that will itself be consumed in turn. There is a quiet, terrifying grace in this cycle. It reminds us that we inhabit a reality that is not centered on our survival or our understanding. We are observers of a machine that was running long before we emerged from the dust, and will continue to grind away long after our own sun has faded. The mathematical indifference of the Finch is a mirror held up to our own insignificance. It shows us a universe that is vast, violent, and utterly unconcerned with the stories we tell ourselves to make sense of the dark. We see a star shredded 50,000 light-years from home, and we call it a mystery, but to the cosmos, it is simply the natural conclusion of a billion-year vigil. The furnace has been fed, the equation has been balanced, and the dark has been held back for a single, ultraviolet heartbeat. In the grand tally of the all, the beautiful chaos of the Finch is just another brushstroke on a canvas that is constantly being erased and repainted, a fleeting light in a system that ultimately demands the return of everything to the silence of the void. Against this backdrop of cosmic indifference, a singular and improbable miracle emerges. On a small, temperate rock orbiting a common yellow star, a collection of biological specks has begun to push back against the darkness. We are fragile, short-lived creatures composed of the very carbon and iron forged in the deaths of ancient suns. Yet we have refused to remain silent in the face of the void. We have constructed artificial eyes, vast mirrors of polished glass and sensors of hypersensitive silicon, and we have turned them toward the deep. These instruments are our bridge between the chaos of the explosion and the order of understanding. They are capable of catching a stray, lonely photon that has travelled for hundreds of millions of years across the intergalactic wilderness, a tiny packet of energy that would otherwise have vanished into the nothingness without ever being known. The act of observation is the most transformative force in the universe. Until that photon struck the mirror of a telescope in Hawaii or Chile, the event known as AT 2023 FHN was merely a sequence of physical interactions, a meaningless fluctuation of energy in a desert of space. But the moment it was recorded, analysed and debated by a conscious mind, it was transformed into a story. We are the ones who turn the beautiful chaos into a narrative. We take the raw, violent data of a 50 billion sun explosion and we weave it into the tapestry of our collective knowledge. By doing so, we ensure that even a lonely fire in the deep is never truly forgotten. We give a voice to the silent suns and a witness to the invisible predators that haunt the intergalactic medium. This is the ultimate role of human consciousness, to serve as the bridge between the mindless violence of the machine and the structured beauty of the mind. We are the universe observing itself, the means by which the cosmos gains a memory. The finch did not just create heavy elements or a hole in the vacuum, it created a question. And in our relentless search for the answer, we justify our existence. We are the bridge builders who look upon the carnage of a shattered world and see not just destruction, but the blueprint for a deeper truth. We live on a scale of centimetres and seconds, yet we have reached out to grasp the mechanics of objects that span light years and endure for eons. This ambition is our defining characteristic, a defiance of our own insignificance that allows us to stand as equals to the giants of the heavens. The story of the finch is a reminder that the most profound insights often come from the most isolated places. It teaches us that the void is not a graveyard, but a frontier where the rules of reality are still being written. As we continue to scan the night, waiting for the next black swan to emerge from the shadows, we do so with the understanding that every new discovery is a victory for the light of reason over the dark of ignorance. We are the ultimate observers, the sentinels who ensure that no matter how far a star may wander, or how violently it may fall, its final scream will be heard and its story will be told. The beautiful chaos of the universe is not a threat to our understanding, but the very fuel that drives our curiosity, a constant invitation to look deeper, to think harder, and to never stop seeking the truth. By seeking these answers, we ensure that the light of the finch continues to burn, not as a physical fire, but as a spark of insight in the minds of those who follow. This is the justification for our journey, that through us, the universe is no longer a cold mathematical equation, but a living, breathing masterpiece of light and shadow. If you feel the pull of the deep, and wish to join us as we continue to map the boundaries of the known and the unknown, consider supporting this exploration. Every question we ask and every mystery we solve brings us closer to understanding our place in the grand, violent and beautiful engine of the cosmos. By witnessing the end of a lonely sun, we find the strength to continue our own story, ensuring that the fire of discovery never fades. Stay curious, keep watching the skies, and remember that even in the most absolute annihilation, there is a story waiting to be told.